Hi, I'm Daniel Champagne. I'm a design engineer with ESC Spectrum, and I was the project manager of the IP CEMS developments.
Hey, I'm Clay Phillips, and I'm a design engineer at ESC Spectrum, and I did the design engineering for the IP CEMS project.
So integrated path CEMS are a laser-based optical analysis method used in a regulatory capacity currently for Part 75 is what we just got the green light for.
So if I had to explain this to someone at a barbecue, I would say that IP CEMS uses a principle called laser spectroscopy. And basically what that means is that we use lasers to figure out what stuff is in the stack at gas power plants. And it kind of works like this. Different gases or chemicals interact with light in their own unique way. Kind of like how a person has their own unique voice and fingerprint. So when we shine light across a stack, it's like asking the molecules, what are you? And the way that they respond is how we tell what's in the stack. So it compares in the sense that it measures the same analytes, and it contrasts in the sense that it removes all of the sample extraction equipment, including the sample lines, the sample probes, the sample conditioning equipment. And it also, using IP CEMS, provides a faster response time compared to normal, typical extractive CEMS.
So laser-based optics and laser-based in-situ analyses have actually been around quite a while. There have been significant hurdles, both on the technology side as well as regulatory approval side. It's been several decades, and there's been a lot of people really interested and involved in the technology. The real innovation would have been the development of tunable diode lasers that allowed for specific targeted wavelengths for the analyses in question for Part 75 applications. And with the developments of ESC Spectrum and what we did with the calibration cell, we're now able to utilize EPA protocol gases. So EPRI's Program 233, their CEMS and integration team, wanted to challenge vendors through a series of trials to prove the technical feasibility and the application of integrated path CEMS in a regulatory fashion. ESC entered the picture in the last of these trials to prove that the technology can be used in Part 75, utilizing EPA protocol gases and meeting QA and QC requirements.
So the way that the TDL and the UV DOAS work in this setup is that they shine light across the stack and measure the power that's absorbed by the analytes within the stack, and doing the calculations for that measurement allow us to know exactly what concentrations of analytes were in the stack.
It was really exciting. It was kind of a surprise to us. It caught us a little off guard. When we approached the EPA's CAP-D and OAQPS groups, we expected to start a dialogue to kind of work together to build a pathway to compliance. But ultimately, EPA's CAP-D and OAQPS groups agreed with us that the approach that we took and the QA/QC that we performed ultimately met the requirements of Part 75 as written. The excitement was readily apparent immediately following that meeting, and it launched a very busy few weeks for the ESC Spectrum team. The biggest benefit that IP CEMS brings to our facilities and our customers would be the annual O&M cost reduction. By nature of being a more simplistic analyses method and eliminating a lot of the sample extraction components, you have less maintenance and you'll have fewer emergency downtime hours as well.
After we moved the system from the ports on the stack to the combustor outlet, when we initially installed the equipment, I was having trouble getting the laser to pick up at the right wavelength of power when I was tuning the UV DOAS. And no matter what I did, I could not get the peak to come over where I wanted it. And we were just trying for 2 hours and could not get it to line up correctly. I eventually called our vendor, and he revealed to me that the type of window that the light passes through kind of filters out certain wavelengths. So what I had done was swapped the TDL and the UV DOAS windows, which was blocking the wavelength of light that I wanted to measure. So no matter what I did, I was never going to be able to see that wavelength. So once I swapped the windows, everything was easy to tune right in. So it was kind of like an aha moment. So I definitely nerded out over the fact that we are literally watching atoms and molecules transition between quantum states. The molecules that we were interested in measuring resonate with light at specific wavelengths. So when the tuned light hits the atoms, they absorb some of the power. And that's how we can tell what concentration of molecules are in the stack.